Your car is running rough, fuel economy has dropped by 25%, and the check engine light won't go away. The shop quotes you $400 to $550 for a new sensor. What they don't tell you, and what SAE technical research confirms, is that in the majority of MAF-related fault codes, the sensor isn't failed. It's dirty. A $10 can of the correct cleaner and 15 minutes of your time resolves it completely. Stay here, because this video will save you real money today. There is a sensor inside your intake system so precisely calibrated that a layer of contamination thinner than a human hair is enough to corrupt every fuel calculation your engine makes. It's called the MAF Airflow Sensor. According to automotive diagnostic data compiled by the National Institute for Automotive Service Excellence, MAF sensor faults consistently rank among the top 10 most commonly misdiagnosed engine management issues in passenger vehicles. Most drivers have never heard of it. Most shops won't explain it honestly, because a cleaning they can't charge labor hours for is less profitable than a full replacement. Here is exactly what it does. Your engine operates on a stoichiometric air-to-fuel ratio of 14.7 parts air to 1 part fuel under normal conditions, a figure established through combustion engineering research and built into every modern ECU calibration. The MAF sensor is the primary input device responsible for maintaining that ratio in real time. It sits directly in the intake path between the air filter housing and the throttle body. As incoming air passes across its internal sensing elements, either a hot wire filament or a hot film membrane operating at a precisely maintained temperature above ambient, it measures volumetric airflow and transmits that data to the engine control unit hundreds of times per second. The ECU uses this live airflow data to calculate injector pulse width, meaning how long each fuel injector stays open per combustion cycle. Clean sensor, accurate data, correct mixture, efficient combustion. Contaminated sensor, corrupted data, wrong mixture, wasted fuel and lost power. Research published in the SAE International Journal of Engines confirms that even a 10% deviation in MAF sensor output causes measurable increases in fuel consumption and hydrocarbon emissions. A sensor reading 10% low causes the ECU to underfuel, producing lean misfires, rough idle, and potential catalytic converter damage over time. A sensor reading 10% high causes overfueling, rich running, black exhaust smoke, fouled spark plugs, and fuel economy losses that owners typically attribute to driving habits rather than a sensor fault. The symptoms are specific. The first is hesitant, flat acceleration, a delay between throttle input and engine response that feels like the engine is guessing rather than reacting. The second is unstable idle, sometimes with a fluctuation between 500–900 revolutions per minute that you can feel through the seat and steering wheel. According to automotive engineering data, idle instability caused by MAF contamination is frequently misdiagnosed as a vacuum leak or a failing idle air control valve, leading to unnecessary parts replacement. The third symptom is measurably worse fuel economy. Documented cases in independent automotive research show fuel consumption increases of 10 to 25% from MAF contamination alone. The fourth is black exhaust smoke or a raw fuel smell, both indicating unburnt hydrocarbons escaping the exhaust, a direct result of overfueling from corrupted airflow data. And fifth is the check engine light carrying OBD2 fault codes P0101, P0102, or P0103, all of which the Society of Automotive Engineers defines as mass airflow circuit range, low input, or high input faults respectively. Here is what the industry data actually shows. A 2019 study by the Automotive Aftermarket Suppliers Association found that MAF sensors are replaced at significantly higher rates than failure data justifies, suggesting widespread over-replacement driven by diagnostic shortcuts. Shop-proven experience across thousands of service cases confirms the same finding. Cleaning resolves the fault completely in the majority of cases where the sensor's internal elements are physically intact. Before the cleaning process, the tools and the critical warnings. You need safety glasses, gloves, a screwdriver or small socket wrench, a clean lint-free surface, and one specific product, a dedicated mass airflow sensor cleaner. CRC, Johnson's, and WD-40 Specialist MAF Cleaner are among the formulations specifically engineered to evaporate completely without leaving residue on sensing elements. That last point is chemically critical. Never substitute carburetor cleaner, throttle body cleaner, brake cleaner, or standard WD-40. These products contain petroleum distillates, lubricants, or aggressive solvents that leave residue on the sensing elements or chemically attack the protective coatings on hot wire filaments. Research from Bosch, one of the world's largest MAF sensor manufacturers, specifically warns against non-dedicated cleaners in their service documentation, noting that chemical contamination from incorrect cleaning products can permanently alter sensor calibration. Never use compressed air. The mechanical force from even a standard shop compressor is sufficient to physically displace or snap the sensing filament, which in hot wire sensors operates at approximately 100 to 200 degrees Celsius above ambient temperature and is structurally fragile by design. And never make physical contact with the internal elements using any tool, cloth, or swab. Bosch engineering tolerances on MAF sensing wires measure in microns. One touch destroys calibration permanently. Now the process, step by step. Engine cold, ignition off. Locate the MAF sensor along the intake tube between the air filter housing and throttle body. Press the release tab on the electrical connector and pull it straight back, never by the wires. Loosen the mounting hardware and remove the sensor with a careful twisting motion. Bring it to a clean surface in good light. Hold the MAF cleaner can 4 to 5 inches from the sensing elements. Use short, controlled bursts, never a continuous stream. Rotate the sensor between sprays to ensure all surfaces of the sensing element receive coverage. 10 to 15 short bursts is sufficient for typical contamination levels. The solvent penetrates and dissolves oil film, dust binding agents, and particulate deposits that accumulate on the sensing surface over normal service intervals. Set the sensor element side up on a clean lint-free cloth. Allow a minimum of 15 minutes for complete solvent evaporation before reinstallation. Research from sensor manufacturers recommends this drying period specifically to prevent solvent vapor from causing a temporary short-circuit condition on first startup. 30 minutes is better. Do not apply heat. Do not use compressed air to speed drying. Solvent evaporation is the only acceptable drying method. Reinstall with the directional arrow on the sensor housing pointing toward the engine. Tighten mounting hardware firmly but without over-torquing. MAF housings are typically plastic or light alloy. Reconnect the electrical connector until it clicks. Start the engine. ECU recalibration begins immediately as the engine management system receives accurate airflow data for the first time since contamination built up. Idle quality typically stabilizes within 30 to 60 seconds. Full fuel trim recalibration, the process by which the ECU adjusts its learned fuel maps based on new sensor data, completes over approximately 50 to 100 drive miles according to manufacturer ECU programming documentation. Fuel economy returns to baseline figures within that recalibration window. When cleaning is not enough. If the sensing wire is visibly discolored, corroded, or broken on inspection, replacement is the only option. If cleaning is performed correctly and identical fault codes return within 1 week of normal driving, the sensing element has worn beyond recovery. In replacement scenarios, OEM specification sensors or established brands including Bosch, Denso, and Delphi are consistently recommended in automotive engineering literature over budget alternatives. Independent testing published by Consumer Reports and automotive trade publications has documented early failure rates in low-cost aftermarket MAF sensors that are significantly higher than OEM equivalents, making the price difference a false economy in most cases. The measurable bottom line: a $10 to $15 can of dedicated MAF cleaner and 15 minutes of time resolves the fault that shops quote at $400 to $550 in parts and labor, in the majority of cases where the sensor's elements are physically intact. That is a documented, research-supported repair that every car owner is capable of performing. If this just kept hundreds of dollars in your pocket, hit like right now, share this with someone sitting on a shop quote for a sensor replacement, and if you want to save $500 on your next repair, hit subscribe. Drop a comment and tell me what country you're watching from. I read every single one.